getting recognized with the patterns here. So 1 and 2 are basically the same thing. You want to go ahead and rewrite them in terms of sines and cosines. You wind up with sine over cosine, which therefore is tangent. 2, same idea. You wind up with cosine over sine, which is cotangent. As you get to 3, I think we did this example in class when you have tangent over sine, split them apart as 2 separate fractions. As you split things apart as 2 separate fractions, you have tangent over 1 times 1 over sine. And then you know you can rewrite tangent as sine over cosine. And then you have your sines drop. You have 1 over cosine, otherwise known as secant. Okay? Gee, if it was only posted online and with PDFs and all that stuff, it would have been there. Gee, it's only March and I haven't been doing this forever. Okay. Yes, ma'am. I'm getting there. I'm getting there. Okay. 3 and 4 are both basically the same problem. Yes. Number 5, you got a foil. When you get to 5, you FOIL it out, because if you notice, that's a difference of squares. You get 1 minus sine squared, otherwise known as cosine squared. Same thing with 6. You get secant squared minus 1, otherwise known as tangent squared. 7 and 8 are very similar. Just rewrite everything in terms of sines and cosines. You have cosine over sine times sine over cosine, otherwise known as 1. 8, you wind up with cosine over sine times 1 over cosine times sine. In other words, again, 1. Everything doesn't always equal 1. Number 9.
Well.
Yeah. As we're saying, you get sine over cosecant. Bring the cosecant up, you get sine squared. And then you have cosine over secant, which you bring up to secant, you get cosine squared, and sine squared plus cosine squared is, in fact, 1. Let's see. In 10, yes, ma'am.
Yeah, I got it too.
Wait, did I do something wrong when I read that? So that's sine. Sorry. No, this is 1 over. Oh, I know what I did. I think when you split it as 1 over. You split it half. You split it over as 1 over sine.
Oh.
We didn't bring it back up. I just overlooked it. So that was my fault. Because this is the same thing as 1 over cosecant. 1 over cosecant is sine. So you get sine squared. And the same pattern works with secant. I might have just glanced at it real fast and I just didn't catch it. So I apologize on that one. I just didn't see it. Okay.
Yeah.
1. Because you get sine squared, and this becomes cosine squared. Sine squared plus cosine squared is 1. Okay. All right. 10. 10 we have cosecant over sine minus cotangent over tangent. Same basic idea. Split them apart. We get cosecant times 1 over sine minus cotangent times 1 over tangent. I know 1 over sine is cosecant. So I get cosecant squared. 1 over tangent is cotangent. I get cotangent squared. Well, cotangent and cosecants, when they're together, when they're squared, it's a Pythagorean identity. So I look at my Pythagorean identities and remember it. Cotangent squared plus 1 is cosecant squared. So if I move the cotangent squared over, I get cosecant squared minus cotangent squared. Again, otherwise known as 11, when you rewrite, you wind up with secant squared minus 1. Gee, that's a tangent squared. 12, you rewrite, you wind up with, again, same idea. You have secant over cosine, and then you have minus secant cosine. So here, when you're multiplying the reciprocals together, you're always going to get 1. When you divide them, bring the denominator up, it becomes squared. So you have secant squared minus 1. Again, it equals tangent squared. 13, you can do a couple of different ways. A lot of times when I see this, I'll start thinking, I can rewrite that in terms of 2, it has a common denominator and split it into 2 fractions. That's one way of doing it. I think that's the easiest way. If I do that, I get 1 over tangent squared plus tangent squared over tangent squared. And that way you get cotangent squared plus 1, which is cosecant squared. You can't really split this one apart. You have to go right to you have to go to the Pythagoreans. 1 plus tangent squared is secant squared. And then 1 plus cotangent squared is cosecant squared. So you wind up with secant squared over cotangent squared. Split apart the fractions.
Wait, 1 plus cosecant?
Oh, I'm sorry, I meant cosecant squared. Pull apart your fractions, okay? You get secant now I'll rewrite them in terms of sines and cosines. Multiply those to get sine squared over cosine squared, which is, there you go. The 50 degrees, the 350 degrees means the same thing. As long as they're the same value, all the properties work. So then just so happens you just have theta values instead. So cosine squared plus sine squared is 1 plus tangent squared is secant squared. So yeah, yes sir. All right. So secant over cosine is secant squared. Because this is secant times 1 over cosine, which is secant times secant. So you get secant squared. Then you have minus secant cosine, which is 1 over cosine cosine, which gives you 1. That's the proof.
Wait.
No, secant squared minus 1, which is tangent squared. Don't apologize, it's okay. Hi. What do you mean? Because I'm dividing it. When you divide by 2, is it the same thing as multiplying by 1/2? That's fine. I'm just pulling apart the fraction because I know that 1 over cosine I can bring up as secant. Okay, because I'm using reciprocal properties. All right. Yeah. This one. Okay. Verify on the other side. You at least know what your answer is when you're done. Okay. So let's see, we had sine squared times the quantity 1 plus cotangent squared. Yeah, show that equals 1. Well, what is 1 plus cotangent squared? Cosecant squared. So sine squared times cosecant squared, anytime you multiply reciprocals together, you get 1. Done. No, it's okay. 32 is kind of like that. They kind of put these things in pairs with the same basic premise next to each other, so you can kind of duplicate. Okay. Distribute again. Get sine squared cosecant squared. Plus sine squared secant squared. What's sine squared times cosecant squared? 1. Sine secant is sine squared over cosine squared. Tangent squared. Which is secant squared. Bless you. Once you start seeing the 1 pluses and you have some squared stuff, try to manipulate things around and see if you can get one of the identities to work. Okay? These next two are very, very common style as we get to the equation stuff. Same as number 57, which we'll talk about in a little bit. This style of a trick, if you will, pretty right. Notice you start with cosine squared and a sine squared, and you wind up with just 2 sine squareds. That meant rewrite cosine squared in terms of sine squared. So cosine squared is 1 minus sine squared. How many sine squareds do I have? Okay, same idea with number 34. Instead of rewriting it in terms of sine squared, we're writing it in terms of cosine squared. Cosine squared. So now I went from a cosine squared and a sine squared to having 2 cosine squareds. So write sine squared. This is the part you have to be careful with, though. You have to put it in parentheses so you distribute it out correctly. You got to distribute your negative. So you have cosine squared minus 1 plus cosine squared. Thank you. You have to plug, I'll take it. Very, very common trick there by multiplying those things out. Bless you. Yesterday for 35 and 36, I gave you guys the hint of a lot of times when you see addition to start and then you end in multiplication, they had to get common denominators. Okay? So when you look at 35, you have cotangent plus tangent. And you want it to equal cosecant secant. Bless you.
Thank you.
Cotangent is what over what? Cosine over sine. And then you have sine over cosine. Common denominator is when you multiply the 2 together, isn't it? Okay. Fraction on the left needs cosine. Fraction on the right needs a. What's cosine squared plus sine squared? Everson. 36 is basically the same problem. Secant squared, cosecant squared. Same idea. Rewrite it in terms of sines and cosines. Get a common denominator. You have 1 over cosine squared. 1 over sine squared. What's your numerator? 1. What's your reciprocal? How many of you guys went to 37 and said, No,
Oh, I swear.
can't do that.
Yeah, I figured I couldn't.
Nope. Nope.
I did it anyways.
What's that? No, you still have reciprocal. I just stopped. I got bored. We have it one over, right now we're sitting at 1 over cosine squared sine squared, right? No. It's times, it's not multiplying. It's not adding. The denominator. Look at the denominator. Is it cosine 1 over cosine squared sine squared, cosecant squared, secant squared?
Sure.
It's reciprocal. This is 1. And that's cosine sine, reciprocal it, secant cosecant. You're right. Is that a perfect square?
Yes, sir.
Is that a perfect square?
Yes, sir.
Is that subtraction? What's the second parentheses? 1. You're done.
You can't do anything.
No, verify that. This equals 1. You get cosine squared minus sine squared.
Oh, wait, is the first parentheses the never mind.
This one can be kind of messy if you're not sure how to start. Question. I'm looking at this and I'm seeing if I wrote stuff in terms of sines and cosines, I don't think it would get me very far because that middle term would have ended up with like sine to the 4th over cosine. I don't think that's going to be very helpful. Okay. So I start looking around and thinking, like, okay. I start thinking about different properties of algebra that you can work with. Oh, I don't know. Associative property? How you group things? Does that matter when you're adding? No. What do those two terms have in common?
Squared.
What's your parentheses become? 1.
Oh, I got the secant squared from that, but I did it some other way. I don't even know. Can you come look at it? I don't know what I did, but I got to figure it out. This one, I already.
Can't do that position yet. Can't do that. Can't do it.
Yeah.
You just threw stuff against the wall and hoping it stuck.
Yeah.
Yeah.
No.
No.
Okay. You started. No, we're going to try that again.
Sucks. You can see the gears moving.
Yeah, the other one here you didn't write.
Yeah, there's a lot of someone forgot to point those gears. No, there's never been anyone. Half of them.
You wanted to win and I didn't want to go. See how this one's like?
And then the micro are
Like 15 steps to my
sticking together.
All right, let's try some of the other ones.
It's actually the one.
Look at 19.
That's interesting.
Back to a simplify. When you have simplifies, you really don't know when you're done until you can kind of have the smallest amount written up. Okay? So I see sine cosine over 1 minus sine squared. Well, what's 1 minus sine squared? Cosine squared. So right away I know that I'm going to wind up with sine cosine over cosine squared. Now what?
You can cancel it.
Yep, you can cancel out, simplify out one cosine, you wind up with sine over cosine, otherwise known as, there you go. $20 is very, very similar to that. You have in the numerator 1 minus cosine squared, which is another name for sine squared, and you wind up with sine squared over sine cosine, and you wind up again with tangent system. 21. Secant minus sine tangent. There's no squares here. I have subtraction. I have secant, sine, and tangent. In my head, really the only thing I can think of doing is just rewrite things in terms of sines and cosines. Secant is, 1 over cosine. This is sine over 1 times sine cosine. Since I'm multiplying, let's multiply my numerators together, my denominators together with the sine tangent stuff. I wind up then with 1 over cosine minus sine squared over cosine. Huh. Do they have a common denominator? Yeah. So you can combine it all together. What's 1 minus sine squared? What's cosine squared over cosine? 1 minus sine squared is cosine squared. Cosine squared over cosine is. Here's the other one. What's cotangent plus 1? Oh, excuse me. What's cotangent squared plus 1? Cosecant. What's going to be cosine times its reciprocal? Or not cosine, sorry. I said cosecant. I meant. Sorry, I was thinking backwards. My bad. Let me redo this one. I'm looking at 22. Cosine squared. Okay. We know cotangent squared is cosecant squared, right? I'm sorry. Cotangent squared plus 1 is cosecant squared. I'll get it out eventually. So you have cosine squared, cosecant squared. Cosecant squared is 1 over sine squared. What do you do?
1 minus sine squared.
Does that get you anywhere? Nope. Cannot simplify that. Cannot simplify that. Does that get you anywhere? What do you say? Is this a perfect square? Is that a perfect square? Is that a subtraction symbol? You gotta factor first. What's 1 plus sine minus 1? There you go. Very common little thing you guys will overlook over and over again as a last ditch effort. You could try and do cosine squared over 1 minus sine, multiply it by conjugates, get common denominators, and try and do all that stuff. but yeah, a little bit easier this way. 24 is basically the same thing. You wind up with secant plus 1, secant minus 1. So you get secant minus 1 plus 1, which just leaves you secant. Let's go to 50. Where things get a little bit cleaner, or crustier, or uglier, or however you want to say it. Okay. That looks fun. Yes, ma'am. Huh? Are you trying to do this?
No.
Oh, thank goodness. Whew, I was worried. No, that's what it has to look. That's what we have to get it to look like.
You don't touch that.
Ding, 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 ding. Don't touch that. Thank you. Thank you. My trick hits me so hard. Makes me say, oh my lord. Thank you for the cosine that. Common denominator. What do you got?
Can you take out the cosecants and then you get
Can't do anything until I get a common denominator. Yes, sir.
Multiply cosecant squared minus 1 by cosecant squared plus 1, you can basically cotangent squared.
Okay. I see where you're going with that.
And then, yeah, so it's just cosecant squared cotangent.
Which kind of gets you the same thing. If I do this is to make sure everybody sees all the little steps. Get a common denominator. Fraction on the left needs the plus 1, cosecant plus 1. Fraction on the right needs the other one. When you distribute all that out, you get cosecant squared plus cosecant squared minus cosecant all over that same denominator, so leaving it like that for right now. What happens to your singular cosecants? Singulars drop, so you wind up with 2 cosecant squared over cosecant, what is that? Cosecant. Now, if I FOIL out that denominator, I get cosecant squared minus 1. You okay with that? What's cosecant squared minus 1? Cotangent squared. Now split and rewrite. I'm just splitting them apart before I flip anything around.
Wait, how do you get cosecant?
Oh, I'm sorry. I looked up. I don't know why I wrote that. I'm sorry. Okay. So here, I've got the cosecant in the numerator, the cotangent in the denominator, which means it's going to be, I bring the cotangent up, it becomes sine. I'm sorry, tangent squared. Bring the cosecant down, it becomes sine squared. So you get and then here's your 2 secant squared.
because it's 1 over cosine squared and that's what, so it's
The cotangent squared becomes tangent squared. Tangent squared is sine squared over cosine squared. The cosecant squared is 1 over sine squared. Random number. But 2 squared plus cosecant squared.
I mean, where does it end up?
And at the end, it keeps rewriting. It winds up 2 over sine squared. Ah, 57.
Oh my gosh.
Okay. When you have squared terms and non-squared terms, you're going to always want to try, especially with sine and cosine. Okay, with sine and cosine. You want to use the Pythagorean identity to rewrite the squared term in terms of the non-squared term. Okay. So sine squared is 1 minus cosine squared. Okay. That way when we get into this, we can deal with just one trig value. So you have 1 minus sine squared. I'm sorry. Cosine squared plus 2 cosine minus 1. The same thing in the bottom. 1 minus cosine squared plus 3 cosine minus 3. Okay? Combine like terms. What's 1 minus 1? 0. Okay. So my numerator is negative cosine squared plus 2 cosine. What's negative 3 plus 1? My denominator is negative cosine squared plus 3 cosine minus 2. Got a factor now. Yes, sir. Yeah, that's the trick. Basically, it's adding everything to the other side, change every sign. Okay? Yes, sir.
So, question, why do we not include like the data and stuff?
It's just messy. Honestly, it's just messy because none of this works unless it's there. If I put an X or a theta in all of it, I mean, my handwriting's pretty awesome as it is. I think it would just mess it up a little bit more. So it's for any of these things to work, you have to have the same value. We'll bring the theta back in when we start doing this with the actual equation parts, but they're not going to be as messy to start with. So change all your signs, your SIGNs. You have cosine squared minus 2 cosine, cosine squared minus 3 cosine plus 2. Numerator. It's first rule of factoring. Plus 2. I changed everything, changed all the signs, SIGNs. Multiplied everything by negative 1.
Oh.
Okay. What's your first rule of factoring?
Don't talk about that.
Starts with G, C, and F. So what's the numerator have in common?
Cosine.
Cosine. So factor out a cosine. We have cosine times cosine minus 2. Isn't this the same thing as saying x squared minus 3x plus 2? What times what's 2 you add together to get negative 3?
Cosine minus 2 deletes.
Okay. So far, so good? Okay. Now, move this up. We're at they want us to have this in terms of secants, I believe, right?
Yeah.
Okay. So if they want us to get to secants, I got to figure out a way to rewrite cosines in terms of secants. Well, isn't cosine and secant reciprocals of one another? This is true. So my numerator then can become 1 over secant. My denominator is 1 over secant minus 1. Remember doing complex fractions not too long ago? Okay. Same thing, same stuff applies. This one's 1 over 1, so my denominator here, I need a common secant. Fraction on the left has it. Fraction on the right needs it. Numerator is already ready to roll. Take the numerator and the denominator, flip it up. What happens? Verified, isn't it? And that's when you have a verified. If this was a simplified, honestly, if this was a simplified, you would probably stop right there. Because it's just in terms of sines and cosines. The fact that it's a verified tells you that you can go further with it by putting in the extra steps. That's the trick on this one. Okay? That's the trick to this one. Because it isn't verified, it forces you to do an extra step. Okay? If this was a simplified, I'd be fine with you guys getting it here. It being a verified by telling you to do something else, you just got to finish out what they want. It's kind of gross, but hopefully it isn't as terrible. Let's see. Real fast, if you look at 47 and 48, that's junk squared for both of those. Make sure you write it out twice. Don't just write cosine squared plus sine squared, because you'll be wrong. Okay? You guys should be able to get through 39 through 56. I'll give you a little bit of a hint. When you're looking at ones like 53 or even 49, think conjugates. How did we get rid of square roots in the denominator? So if your denominator is 1 plus the square root of 3, what would you multiply top and bottom by? Nope. 1 minus the square root of 3. So if your denominator is 1 plus cosine, what would you multiply top and bottom by?
1 minus.
That's the trick with some of these things. You wind up multiplying by conjugates to be able to create Pythagorean identities. Yeah, go through the 39 through 56. We'll check some of those tomorrow. And then I got one last little bit of this stuff to go through, and I think we'll be okay to get into the equation set starting Thursday.
So we say 39 through 56.
39 to
You mean all of them? Or just
Yes.
the two more.
yeah, everybody.
Yes.
No sense.
Thank you.
Yeah.